And
Yep.
that was actually cool because today we discovered that the cleaning lady from our office is taking coffees at 7 a.m. That's awesome. Thank you, cleaning lady.
Hello everyone and welcome to Coreflux Connections, our webinar series where we sit down with digitalization experts so we can learn from their experience and unique perspectives on the state of the Industry 4.0 and IoT in general. We're kicking off this series with none other than Dylan Dufresne. He's a digital transformation expert and field integrator of IoT solutions. His experience includes educating customers who are taking the very first step into digitalization. You may have seen him online where he's constantly sharing insightful knowledge on industrial solutions for collecting and using data, or you might have worked with him directly. He accepted our challenge to prepare a simple integration demo, and that's where we'll start. And then stick around to hear the brilliant answers he had for some of our questions about his look on the everyday job of an integrator. Let's go.
Hello, Dylan. Hello, João. Welcome. I hope that everything's running okay for you. I think for this today's webinar, we prepared a small presentation based on some workaround.
So, in our case, many of our coworkers are taking coffee during the work time. So, in this case, we just wanted to monitor how many coffees are taking during the day. Dylan, help me out here.
Yeah, we're good. Yeah, so you guys wanted to. The question coming here is we've got these plugs and devices plugged into the broker here right now. You guys called me to help you guys solve a problem, come up with a solution on something with that coffee machine, right? You guys wanted to know kind of how much coffee you were using, how many times that coffee machine was running a cycle. And one of the ways we identified to count that and store that information so that we can derive the different events and all that was to use the Shelly plug. And so that we did that. We plugged it into that Coreflux broker. Everything's seamlessly integrated there. From there, we can monitor the power, the current, and the voltage. And we'll show you later in the demo how we're doing it. But we're using Node-RED to subscribe to the topics from the Coreflux broker. And one of the things we're doing is sending an email whenever a coffee is made. And then the other one we're doing is storing the time series values of the current, power, and voltage so that we can later analyze them and learn more about this machine. And then we also, while we were there, we realized that people were leaving the lights on after they made coffee, maybe after hours or something. So one of the things we added was the ability to turn the lights on and off remotely through the broker as well using another Shelly device.
Okay, basically we are building a use case, and of course it's a small presentation, but we can almost put this as a real use case from a shop floor in a plant where we simply monitor the consumption, what is the outreach of each machine in terms of metrics and so on, and from the power consumption really know if the machine is being used, how many times it's being used, and then associate this with a production log from that point forward. Okay, so I think this has really into a real case in terms of usability, and we can see and explore the potential from this solution coming out from here. Okay, so let's see what you guys are talking about, and see from there what we can get. Great.
Yeah. Well, first of all, I think we can begin by showing our broker and what's connected to it. Right now, I'm going to share my screen so everybody can see what's happening there. Just a second. So over here is the MQTT Explorer. We're showing our broker and what's connected to a broker. And these are the topics that the Shellys are acting on. As you can see, there's the server room, the kitchen, and the meeting room. In this case, we actually did the demonstration only using what's plugged in the kitchen. We've used a Shelly plug for it and also a Shelly connector, if I'm not mistaken, to the lamps and the lights in the kitchen balcony. So in here we can see the status of the lights. At this moment it's on, so we have a signal coming in as true. We also have the events from it, which show some information about it, such as timestamp, the ID, and energy by minute, and also the status topic, which show us more concrete information. Just a second, where is it? Which show more concrete information, such as, oh, it's here, such as source, the output, the A power voltage, frequency, current, and yeah, with this information we can do many things.
We'll get into details later.
I just wanted to say that it's a great way of showing that it doesn't necessarily have to have industrial what's the word? An industrial context, so we can use these things and these devices. In this case, we're just literally just plugged into a coffee machine, so we can read all the metrics from it, and also from the lights. So everybody, most of the people have those things at home. So Dylan, can you show us the Node-RED architecture, beautiful architecture that you did?
So yeah, so in the Coreflux broker here, this is in the Porto office of Coreflux. In the kitchen on the balcony, we've got a plug. This is our Shelly Smart plug, and this is where we have the coffee machine plugged into. We also have a lamp that we use to light the room. So between those two, those are the two devices that we're going to be monitoring and controlling for this demo. Under status here of the plug, this is where we see our payload that we're going to be working with for the first part of this demo. And in here we have power, voltage, and current. Those are the two that we're looking at more than anything. But we do have some other information in here. We also have some of the device temperature, some total energy consumptions, and things like that that we could use in the future if we wanted. And we'll look at the lamp when we get to that part of the demo. So from there, we also started off with Node-RED. So just kind of walking you through here how this flow works and what we built and why is we're starting off with a pretty simple MQTT node. So from here, we're just monitoring that topic. Here we are connecting to, and you'll want to edit this out, we're connecting to our cloud broker. We added our security and all that, and now we're connected to the Coreflux broker. We can debug for some testing stuff, and then we go down our first path here. So the first need was that we wanted to send an email alert every time a coffee was made. So to do that, we isolated the current. So we're only looking at the current part of that payload. And then here we can start detecting the coffee. This is a rising and falling edge. So whenever our current rises above 5 amps, we have an event, and it doesn't give us another event until it falls below 1 amp. That helps us filter out the noise and make sure that it's a real coffee that was made. Because sometimes this coffee machine will just kind of run itself as it goes to keep the pumps warm and keep itself clean and all that, and got to filter out some of those events in order to find the real one. And then, yeah, on the rising edge of our detected coffee, we're going to write our email. And all we're doing for this is sending a coffee was made and an alert to João's email address here, which we can edit out. I don't need to show that. And yeah,
My
so
email is full of coffee.
yeah. We sent him a lot of spam through all this, but that's the demo. Yeah. So in the real world, we might want to simplify that a little bit. Maybe you could add things like a on-call roster and send the email notifications to whoever's there. There's other ways you could do it too with push notifications and things like that. But to keep it simple for the sake of this webinar,
database.
And that was actually cool because today we discovered that the cleaning lady from our office is taking coffees at 7 a.m. That's awesome. Thank you, cleaning lady.
Yeah, so this first flow up here, pretty simple. All it does is subscribe to that topic on the broker that we showed you before. And whenever the current rises above 5, we have a rising edge event that sends the email to say a coffee was made. And that's about it. Pretty simple. The next offshoot here, the next path we have for the plug is here we're splitting our payload into multiple messages. So it comes in and it starts with a single large JSON object with key value pairs. And what we're doing is we're splitting these key value pairs each into their own message, which then we filter out even further. So we're only looking at these 4 metrics: power, current, voltage, and output. And through this is where we're logging to a time series database to allow us to have a historical representation of our coffee machine. With this historical data, that's where we can start running some analysis and start learning more about when, where, and how coffee is made. Over time, we can start to see maybe there's some degradation in the machine, things like that. Yeah.
Nice.
And then here,
Nice.
we'll get into
Awesome.
these a little bit later here. This is some of the stuff we're using for our front end to display the current and the voltage on a dashboard. So with that,
Can our producer make a coffee for us just so we can see this UI happening in front of us?
yeah, so before we get to the UI, actually, let's show you the basics of this flow. So right now we have all of these debug nodes up here, all these dark green ones. The only one that's enabled is this email debug. So every time an email is sent, we're going to get a debug message over here of what that payload was that got sent to that email node. So yeah, João, if you could make a coffee for us, that would be awesome, and we can see how it works on the dashboard here. But before we do that, we'll be nice and let you do it in the light. So we'll turn the lights on here for you.
Please.
Okay.
Our man needs to see.
And there's a coffee being made.
There he
Looks like
goes.
he's
Yeah.
got started. Looks like he's just about done there. And now that he's done, we don't need to bother him, so we're just going to turn the lights off for him. One less thing to worry about.
Yeah. Perfect. Yeah.
Let's show you that here. We'll come into our Influx cloud here. And give me 1 second. I need to remember the password.
Just don't hack me afterwards, okay, Dylan? I beg you.
You've got a wonderful producer who can edit all this out for you.
Yeah.
So yeah, back to kind of what João was saying here about the threshold here. We're going to show you why we have that in here, and we'll show you how that rising edge node works. But we'll give you some more context of that by looking at the time series historian. So yeah, so when a coffee is made, we can see exactly what that looks like over here in our historian. So we're going to select our kitchen bucket, and we did this pretty quick, but yeah, let's look at our current because that's what we're controlling off of. We're going to find our value. We're going to find the past 15 minutes just to keep it a nice simple chart. And yeah, so here we can see our little graph of coffee being made. Let's go to the past 5 minutes. Maybe we can see. So yeah, so here in the last 5 minutes, you can see we made those 2 different coffees. You can kind of see what those events look like and how there's a little bit of deviation. They're never really quite the same. There's other parameters acting on that. But we do know every time we make coffee, if I zoom out to, let's say, 3 hours, every event gets us over, it's hard to see on this graph here.
About almost 5,000 of current, right?
Yep, so this is current, so this is just going to be 5 amps if I'm reading it right. But yeah, every one of these, every event that's actually a coffee being made is spiking over 5 amps. And then down here, you can see that it's turning that pump on, running some water through the coffee machine. So part of the cleaning cycle, running the heat exchanger to kind of keep that water hot and ready for when somebody does make a coffee. So we don't want to read these events as coffee being made, but we do need this event. So what we're doing here is in node red, we're using this edge detection node. It's called the hysteresis node, if anyone's following along at home. And here we have a threshold of 5 on the rising edge and a falling edge of 1. So if it goes above 5, that's an event, and we won't get another rising edge event until it drops below 1 and back above 5. Yeah. And that's how we're kind of filtering out. And then here, that's where we're detecting it. So if you follow off that, then we're finding our edge is our rising edge, and only the rising edge before we write an email. And that's kind of how we're filtering out those different events to only kind of find the one that matters for us right now. But since we have this historical data, and we've been running this for a little over a week now, and once we run it for more weeks, more months, a year, we've got all this data now that we could use for machine learning and time series analysis and other ways of learning more about our machine and how it operates over time. And with that, for this example with the Shelly plug, we're logging our power, our current, our voltage, and our output. Yeah.
Nice. And that way, this could be integrated like in industrial area just as easily as we're doing it at home, at our office.
Yeah, and from here, there's an API you can interact with, and if you wanted to go further on the dashboard, we can start showing trends on this dashboard. We can interact with other nodes. If we're going into the industrial scenarios, maybe there's a SCADA system we want to show a trend line on, or things like that. Maybe there's a machine learning platform where we run this through an algorithm to count, or once we have that history, we can say what was our count for the last hour, the last day. We can start to find those peaks and valleys of those events. And that's where a lot of that value comes in. And then from there, we can publish that right back to our Coreflux broker and share that information with everybody else.
Yeah.
Nice.
That's great. Yeah, with this approach as let's say an open platform and open connectivity between multiple systems, it gives us really the chance to, as time goes by and we have more and more data, more information, we can start thinking about the implementation of these solutions for machine learning and all this type of value increase on what we already have. That's really great. Yeah.
That way, we could also predict when our coffee machine would start failing based on the stats that we're receiving in that InfluxDB and those graphs. I mean, if I doubt that in a year from now, those current and those metrics would be the same as from now. I mean, the degradation of the machine would happen in any way,
I mean, just some theoretical stuff. It kind of depends on the actual coffee machine itself, but once you start collecting that data, you can, in theory, use that. Maybe you can look at the power output, and based off the power we're using, maybe we know that there's a clog in the line and the pump is running harder, and things like that.
Exactly. Yeah.
And then we can do alerts, and, notifications, and events, and all that. So yeah, that's
very nice.
Any more questions or things like that? Anything you're curious about on the coffee machine before we move on to the light switches?
No, for me, that's a great example of something that it doesn't have a direct connectivity, but where we can really collect data with a simple solution. And really, from that point forward, we can start to really implement better solutions in terms of future maintenance and so on, or direct access to information from the device itself.
Yeah.
This is a really great showcase.
Yeah. So
and in the end, what we did, it wasn't expensive at all. We spent 30 euros with the Shelly's devices, I guess. The Node Red was for free, the Influx was for free, and I mean, our broker, not so free. That's
of course still. Yeah. No, it's a really great solution. I'm curious about the lights also. Yeah.
Yeah, so
Dylan, do you want to show it?
yep, I'll show you that here. I think we should pause here a second. I'm in as quiet a room as I can get, but there is a train driving by. I don't know if you can hear that in the background, so sorry to interrupt. I just heard the horn going and didn't think we wanted that in the recording. But yeah, so to summarize the coffee machine example here real quick, what we've got is two physical devices out in the field sitting in the kitchen, one controlling the lights, and we're going to get into that in a little bit, and the other one monitoring the power consumption of the coffee machine itself. We've got Coreflux Cloud Broker as the glue that's holding all these nodes together. Everything's kind of moving through there and centralized through that broker. And then from there, we've got Node Red, which is the node that is listening to those topics and handling our logic flows and storing the data in Influx, our node that we're using for our time series historian.
Perfect.
Yeah. Sorry, Dylan. Just to highlight this. So I know that this Shelly power plug also has some interconnectivity, let's say. So from here, we could also potentially have just a small interface to just on and off this plug. For instance, after closing hours, like 10 o'clock in the evening, just power off the plug. And then in the morning around 6 o'clock, because people start at 7, like João mentioned, our cleaning lady, and we want to have her taking the coffee. Yeah. So we could power on automatically the plug at 6 o'clock. So do you think it's possible? Of course, it will be possible to have this time schedule from there. It would be quite useful also to have this, because again, during the night, I don't care if it's doing the maintenance or not. I just don't want it to be consumption of any power during that period.
Yeah. Using Node Red here, we can and the MQTT connectivity from that Shelly plug. Node Red has a really good node for handling cron jobs, so you can say at a specific time of day, run this event and make sure it's off. And if you're out within that window, make sure it's off if it's not. So yeah, that's the big example. The light switches are very simple relative to that. So just for the sake of all this here, we are also spamming Joao's inbox with light switch events. So every time someone turns that switch on and off, he gets an email, whether we're doing it through MQTT or not.
Yeah, our producer in the end will be able to edit my email, just a print screen of my email, please, our producer. I'll show you the print after this so everybody can see how spammed I am right now.
Yep.
But yeah, that's cool. That's cool.
Yeah. But yeah, this is a really good example of taking a Boolean value, just on or off, from the device and reporting on exception. So from here, we're subscribing to our light status, and we are saying if our payload, so actually let's start over here. So we're starting here. Let's look at the MQTT payload for this lamp. So the lamp has a status and a command here. And the status, we're monitoring the status to send those emails to Spam Joao's inbox because it's kind of fun. And here on the lamp, we also have our power, voltage, frequency, current, and all of that, which in a second phase, we could also be logging all of that data as well. Currently, we are not. But the one we're really looking for here is this output key. So that is it on or off? And that is telling us the active state of that switch. Then that's combined with the command that we're going to get to in a little bit, which is just a raw value, not a JSON, of the string on or off. Nice. So doing that, we're looking here at this report by exception node. Node Red calls it a filter node. And we're saying if our payload output changes, we're blocking it. So if we get true once and we get true again and true a third time, we still only have that one event because it hasn't changed. So there's no reason to spam the broker, spam the emails, or anything else like that with values and the network and all that with data that hasn't changed. So report by exception here, we're saying, has it changed? And if it has changed, we are setting our payload of the balcony lamp was turned off, and it's a light event. And we're sending that to Joao's inbox. And we're doing the same thing if it's off. And that's pretty much the same thing we're doing with the coffee monitor. But instead of detecting a rising and falling edge of an analog signal, we're detecting a change event on
a change of the output.
Yep. And then on top of that, to be able to display that on our nice little dashboard, we are also setting our text. Just if it's true, it's on. If it's false, it's off. Using these nodes, these little things here to clean up the flow a little bit, that comes over here and sets our text on our dashboard object. So if you look here,
nice.
That is what is driving our label right here, on or off. And we'll show a little bit more of the whole front end there when we get there, but the other part of this was that command I told you about, where it is just the string commander of on or off. So for debug purposes, we left these inject nodes in here so we can change it without having to go to the dashboard during development. But we also have these buttons that we saw on the front end that also send that same payload of just that string to our broker, and that is our switch 0 command. And from there, so whenever we hit this button on the lamp, I'm going to turn on the on and off debug so that we can see this happening in real time. And first, we're going to hit it from these inject nodes. So I'm going to turn the light on. Then I'm going to turn it off. And if there's anybody in there, they might think they're at a party right now because the lights are flashing. And we'll be nice, and we're going to stop that for a minute here. And we're going to go to the front end. And I'm going to drag on my responsive screen here a little bit over here so that we can also see the broker while we're doing this. So here we have our switch 0 on. We sent our on command, and we see our payload of our status changing, which we're also observing on the front end here. But yeah, we can turn the light off and we can turn the light on. And we'll turn it back off because that's how we found it, and it's good to leave things where you found them. Yeah.
It's really nice. Really nice.
I guess any...
Really nice. We could do that also in the MQTT Explorer, right?
Oh yeah. Yeah, you can still send, you can publish the same payload right here. So like in the Explorer here in our command topic, let's make sure I grabbed it here. Yep. We should be able to send raw on and publish that right there. And if we come to our dashboard without pressing any buttons, we see that it is on. And if we do the same thing here,
really nice.
Type in off, you see the status update to off.
Really nice. And there's endless possibilities in there, from messing with the rest of your family to industrial area. I mean,
I still think we need to make a function that flickers the lights on and off 5 times with a 20% chance every time you make a coffee. So every time you make a coffee, there's a random chance that it might flicker the lights on you, and then you can start pretending there's a ghost or something.
Yeah, something like it. Yeah, it will be nice. Yeah,
really nice. Really, really nice.
Really nice. I don't know if do you want to show something else related to the influx DB?
We didn't get too much further with the influx stuff here.
Okay.
But at this point, we have the connect, collect, store part. We have a little bit of visualization started. So phase 2 would be to complete the storage of the light switches and then start analyzing that data once we have enough of it collected. We're not going to have time here right now.
As a basic example.
Oh yeah, it's simple. It would just take a little bit more time than I think we have in this, but combining this chart node
Mm-hmm.
with our InfluxDB in.
Mm-hmm.
I'd have to look at the docs to remember exactly how to do this, but here you can write your query.
It's okay, no problem.
All right.
Mm-hmm. Yeah, so we were talking about the also the utility for the lights on and off,
Mm-hmm.
and also based on that, what we could also do this for the power plug to control. Let's say during the night, we don't need to leave it on, but we should also schedule when we want to power it on. So I think it was a really good example of what we were talking about. And also after that, of course, creating a history on how to place this into a database and to have this historic to later work on.
Yeah, so this one, we're not going to get too deep into making it, but this cron plus node right here would be a good trigger for both of those things. So on here, you can say, you can set up a cron job. So you can come in here and say,
okay,
you want to run this every minute on the minute, every 10 minutes, every day at a certain time. And you can set up cron jobs within Node-RED to set up events. And off those events, you can do things like turning the lights on and off, turning the plug on and off. You could run every hour, you could run a script to get your count of events for that hour and log that to a SQL database, or send that back to the broker for another dashboard or another application, and things like that.
That would be great, yeah. Good, good. I think this is really a brilliant use case of the potential that we can bring out from a simple solution.
Yeah, and I think it's good to note too that as I've been turning the lights and stuff on and off here and watching the power, I'm doing it from the other side of the world, not local.
Yeah,
not
exactly.
on premise.
So
This
we
is
are
all
not together.
Yep, this is all through the cloud. And
everything remotely.
yeah,
this is the advantage of working through the cloud and the potential use cases that we bring from there.
Yeah,
great. Okay, so I think I don't know, João, if you want to add some more, or if we can invite also Hugo Vaz to join us and talk a little bit about our broker and so on. Yeah.
Yeah, I'm gonna be living here in order to Hugo come. So guys, don't forget to subscribe, like below, subscribe, LinkedIn, everywhere. Thank you very much for watching it.
Yeah, thank you. This was really a nice presentation, Dylan. So tell me one thing. So you usually on daily basis, this is what you do? Or
as much. Sometimes.
Okay, as you would like, or
not as much as I would like. Sometimes I do. A lot of what I do on a daily basis is still educating that this is still possible. So day to day, I mean, I'll do everything from, some days I'm just programming a PLC and an HMI. Other days I'm implementing and building MES systems and SCADA systems and everything in between.
Yeah.
A lot of where tools like Node-RED have come in for me is as a supplement to existing brownfield sites. So when you don't get to start from scratch and start with the tools you want, Node-RED's usually a pretty good addition to other things. So
yeah, that's really interesting because again, it's a very simple tool in order to implement this type of logic. Of course, if you work every day on PLC basis and controller logic, for sure you're doing it locally on the device itself. But for certain solutions, it makes perfect sense to not have this dependency on local hardware. And if you have access to all the equipment logic into a centralized broker like our cloud broker, from there you implement this type of solutions with a very simple and intuitive tool like your Node-RED.
So and let me jump on there too quick because a few years ago, before some of the tools like Coreflux and the assets you guys have to connect to the PLCs and things like that, 3-4 years ago, those weren't really on the market at all. And so what I used to do a lot is when there was just a PLC and an HMI maybe there wasn't a larger system or a larger data collection, then I could easily throw something like Node-RED there to connect to the PLC and log to a local influx database. And now you have some time series data. You can build some charts and dashboards, maybe a SQL database to log events and things like that. But the problem with that is it's not part of a larger system. It's just as isolated as that HMI was, where we're using Node-RED to get some of the value that we can't do in that HMI. So it's an addition to an HMI or an existing to a legacy SCADA system, but it's still isolated on the edge. Using some of the assets and things like that, now we can connect Coreflux to the device, the PLC, read the tags there, and then we can get this stuff out of the edge and into the cloud, into a site level broker, into an area level broker. You can start to get it so it's no longer so localized and isolated. So using something like Coreflux and their assets to pull the data from the PLC instead of Node-RED lets us much easier connect that machine into a larger infrastructure. And from there, we can still use a lot of the same tools we're using before, but now we're no longer isolated to the edge.
Exactly. Okay. Yeah. This is the really approach that we see for our solutions. Also, a big jump, let's say, that we did in the last couple of years was exactly passing from the local solution and isolated solution into now bigger scale and to bring this out of the edge environment to the cloud environment. And this brings really another chunk of value into the solutions that we are implementing.
And round back to your original question before we turn it over to Hugo Vaz here, is a lot of my day-to-day stuff, what I'm really doing a lot is trying to educate on a lot of the people that are just doing those PLC HMI stuff, whether they're other engineers or maintenance techs or the clients and the end users themselves. It's educating them that this stuff is even possible to begin with. And so you might be taking a brownfield site, something that's already out there, something that's already isolated, and using some of these tools to connect that data in a very easily integrated way, where you're not ripping and replacing any large systems. You're not putting in $100,000, $1 million digital transformation initiatives and large projects. You can just start collecting that data now and growing with it and things like that, so that when you do fail, when you do get it wrong right away, you can very quickly recover and get it right the second time and then even more right the third time.
Yeah. In the meantime, Hugo also joined us here. So Hugo, we were already talking about the potential use cases and exactly what William was talking a little bit about this new approach from when we started, and comparing this back to what we did in the past. How we really implement new value into the things that we do on our daily basis. So, Hugo, what do you think about this presentation about this? We are not hearing you. Hugo, no sound.
Yeah, so now we can hear. Hi. So actually, I was saying thank you, and actually I was listening to what Dylan was saying, and it really resonates to what we really believe how things should be done, especially when you're discussing the brownfields. And in this case, what you guys have done with the coffee machine was a small example of a real-time monitor application for like a line from a specific plant. So I could imagine that you were going to a brownfield, installing Node-RED, connecting data to an MQTT broker, and from that point, monitoring what was happening on the machine. That was the general approach. So means that you probably have a lot of know-how and spend a lot of time on the shop floor, and that's really key for us, at least. So my question is, what do you think are the struggles that we are having nowadays in order for really these platforms and these solutions to be on the brownfields that, for instance, you have mentioned? what do you think are the challenges that we are really facing, Dylan?
The big challenge that I've seen more than anything, most people I run into, I mean, once you get into a lot of the digital transformation, the Industry 4.0 stuff, you get on LinkedIn and all that kind of stuff, and it's very easy to fall for a trap that you start to feel like everybody's doing this and you're behind. And you get a lot of fear in that regard. And a lot of people feel they're behind, or they feel they're being attacked, or they don't even know that they can do this because they're not in those circles. And most people I run into in the real world, I'll say, not so much on the internet, not on LinkedIn, not in all these communities, is they just don't even know this is possible yet. They don't know that it's possible. They're afraid of how it's going to affect their Ethernet networks on their plants, their OT stuff. You've got a lot of legacy mindsets who, even when they know it's possible, are afraid of what it's going to do or how it's going to affect things, or they're worried about you getting into the code and adding layers on top of things. And the big thing for me is to just educate that this is not only possible, it's easy, it's cheap. You can get started really small, and it might not be cheap once you grow it, but it doesn't have to be a big $1 million project to start with. You can start with one small machine, start with one little thing. You can use very cheap tools like Coreflux Asset on a local broker, and free open source stuff like Node-RED and Influx. And you can combine all those, and really you can start monitoring a solution like this for a single machine in a day or two, and have real actionable data on a dashboard of some sort. And then from there, once you know it's possible, that's when the floodgates open, and that's when people start to jump on board and see where things are going. And Node-RED in that dashboard isn't going to be the end game, but it's a really good place to start. Because then from there, you can start bringing in other platforms. You've got some larger SCADA systems, things like Ignition and data ops platforms and things like that you can really scale up into. But people don't know where to get started when all the software is a $30,000 to $50,000, even a $10,000 license cost. And so the big things is, first, people don't know they exist. And then once people do know that this exists, they're worried about how much it's going to cost. And if you start with the big solutions first, even a $50,000 project to get started with the big tools and the right licenses and all the big platforms is oftentimes too much for people. And so then the question is, how can you start small? And that's where tools like this really, really come in. And once people get started, they see the value, they see the stuff. You get a little trend chart on a Node-RED dashboard. You get Influx coming in, monitoring a couple different lines. Now, just simple things like uptime and stuff. You start replacing data, and then they want more. And now they've seen the value. Now you can get those bigger initiatives. But now you've still got your broker. Now maybe eventually you move off to the cloud. You look at things like cloud brokers, and the journey grows from there. But you have to start somewhere. And I'm repeating myself here a little bit, but it starts with, first, people need to know that it's out there, that they can do this. People just don't think it's possible. They don't know it's possible. And when they do, if their first reaction
awareness and education,
it costs way too much, it's too big of a project, we can't afford it. And then the next hurdle is, well, yeah, you can do it in, even with labor costs and stuff, it's not expensive. You can do this you can get a lot of work done in a week with this type of solution. You can get a lot of value done in a week of labor. And when you're using cheap and free tools, 99% of your cost is going to be labor. And then the big one too, once you start getting into these free tools, one of the best successes I've seen is once you can start getting these tools in the hands of the end user, their maintenance teams, their engineering teams, and they can start building these things themselves. One of the coolest projects ever was a client, very, very, very small client. The PLC they were using was an Arduino, and it was just a single servo little thing, nothing big.
Really?
So their budgets were small, and all it was an Arduino.
Yeah.
I think that one was the servo did Modbus TCP. It was a small isolated skid type machine, so it was just the Arduino to Node-RED. Node-RED was the HMI, and we came back a month later.
Simple concept.
We came back a month later to add a little feature to it, and found significantly more features in the application than we left them with. And when we first got down there, nobody even knew what Node-RED was. And so once you can get the things in the hands of the end user and their teams, people who can solve their own problems, that's where things really, really start to happen.
Yeah.
That's a great example.
So actually you kind of answered the two things that I wanted to ask you. Because one of the things that I wanted to ask you is, what do you think it's in order to cover the challenge, what to surely work on? And I was going to ask about edge, cloud, but in the end you mentioned it's people. So this digital transformation is very focused, as you said, on LinkedIn, on talking about technology, talking about code, talking about cloud platforms. Sometimes you see about you unified namespace and all that stuff. But in the end, if you don't have the people on board, the decision makers, the technicians, everyone on board of a project, you get nothing. And that's, I think that the shop floor at least gave me that training in order to have the production manager on board of it. I'm able to stop the machine and make some changes. I'm also trying to figure out what I need to get from the machine, and that's one of the things that I wanted to talk about, this major pitfalls that you mentioned. So it was quite a good answer, actually, that you cover at least two of the questions that I ended up. So regarding people, what do you think, besides not doing it slow, like eating the whole elephant bite by bite? I think that was your approach, at least, to get one feature at a time. What do you think it's more appealing to a plant? So should we do it through dashboards? Should we do it to something that really changed the business? What do you think, from what you have seen on your experience? What is that game-changing moment that everyone says, "Wow, this is the way we should do this"?
It's different every time with every person in every place, because everybody's different. Every manufacturer is different, and exactly what you're doing and how you're doing it's going to change place to place. The whole architecture could place depending on the culture of an organization and the existing infrastructure. And whether or not it's a group of managers with a dashboard, or some small changes to a PLC, or even moving a button on an HMI or a SCADA system, it's always something that helps them in their moment. So you find the audience, you find the people who need help, and you help them. I mean, I think the one example I can give that I got the most enthusiastic response ever from an operator was years ago. We came into a system. I was working for an integrator at the time, and a different integrator had come in and put in a whole system, the whole SCADA system, the whole PLC. They did the whole controls for this facility. And it was all controlled from a single SCADA system. It was kind of a bulk material handling application and routing stuff. And we came in to add a new destination. We added a new bin and modified the routing and stuff accordingly. And one of the things that I did when we were down there commissioning it, actually when we were down there selling it, I think, we were down there and the operator was kind of complaining about this button on the screen. And they had a slider they used to open and close a bunch of gates that they would use numerous times throughout the day to determine how much product was kind of flowing through their system. And right under there was a big red button that said e-stop. It wasn't a real e-stop, it was a software stop. It wasn't a safety thing, but if you pressed that button, everything was going to stop. Regardless of what you wanted, no, are you sure? It was going to stop right now. And it was a half inch below the object that they always needed to use for normal operation. They asked me, I moved it to the other side of the screen for them. We didn't delete the button, they didn't want that. We moved it to the other side of the screen for them. And I've never seen a customer so enthusiastic. It's little wins.
Yeah, I know those kind of.
I mean, it doesn't have to be big things. It's how do you, I mean, from there, then now they know you're there to help. And then the big thing is the example I was telling you about before with Node-RED. It's teaching them how to, so first you got to go in there and show them that these problems are easy to solve. And that e-stop example wasn't really a big transformation one, but it was an example of solving a real problem, really quick and real simple, low-hanging fruit.
Yeah.
But first, you got to go in and show them that, yes, we can do this. Let's throw Node-RED in next to Factory Talk, your SCADA system you're running, and start monitoring bin levels or temperatures of things, and start displaying trends and graphs and charts and logs in ways that you just can't do in the existing system. And once they know that it's possible, then you give them the tools to do it themselves. And that's where I really, really have fun. Is once I can leave and come back 6 months later and see that they made it better. But if you don't get them on board to the point where they're willing to and know how easy it is to do it for themselves, that's the key.
So it's kind of you have to show it for them to see. You're able to get data, write down some data on the device, so you're able to control it. We also have an example that goes to, maybe we can tell a story. We have a customer that in the end, it had a similar issue. So they had this PLC that was controlling the building, and their gas account, they have this huge water heating unit, and they had the set point of the value for that, since it was a building for a stadium, and they were controlling the amount of gas that was flowing to the heating unit, because if you define a set point at 55 degrees or 65 degrees, it heats up the water until that temperature, and it keeps the water under that temperature. And since it was a stadium, it was heating the water for all the stadium. And the issue was that the players, they are very important for the team, and they wanted the set point really high. So they wanted the water to be really almost to the boiling point. So they asked for they will call the guy doing the maintenance. Oh, the water is too cold. Keep that on top. And every time they call, they will complain to the president of the club. And the guy from maintenance would get some bad messaging about, oh, this is not going well. You're not doing your job. And in the end, this was giving a huge bill of gas to the organization. So what we decided to do was setting up a broker that was getting data from the device, the PLC, actually a Schneider, and we just changed the set point at a specific time. And that difference for the gas bill was enormous. So just doing an if then else makes a change. And in the end, the thing is that if you are spending a lot of gas, it turns out that you are burning it. So talking about emissions, or here in Europe, we discuss a lot of that in Europe, and that comes with fines in the end. So also that was added into so a simple if then else cover a lot of value. So it's a similar approach of what you're saying. So it's the same thing.
A couple more examples too that are a little bit more different audiences, right? Exactly what you were saying. And then like talking about the different people who need different things and how to solve them. Another story I can say is I was on another site, and the regional manager, it was a little batching tower. It would weigh up its product, batch it, and put it into trucks. You get your bill of lading, and it would send them on their way. And the regional manager there was constantly worried about the cycle time. Why is this taking too long? They were calling the PLC techs to come look at it and all that. And finally, I went down there to look at it after a couple other guys had. We had sent the maintenance, sent some of the service techs and all that. And I'm down there looking at it. I'm personally kind of tired of getting calls about it too. And so one of the things I did, it took like 3 hours, was when this bit in the PLC turns on, log it to a drive to a SQL database with a timestamp. And then we'd pull it up, and now we knew that trucks would wait here for this amount of time, then they'd get weighed in, and they would wait here for this amount of time, then they'd be under the batching tower, and then it would take them this amount of time to get checked in there, and then it would take this amount of time to run the process. And we found the manager there was just having a terrible time because customers were saying it was taking too long. The drivers were sitting there waiting for their turn, and he was getting all sorts of calls from his customers asking about why it's taking too long and maybe we need to go somewhere else. And by putting in that 3 hours of work to make that table log how it was logging, we threw together a very simple dashboard that you could see for each truck how long it sat at each station. And we found one operator that just wasn't getting to it in time, and move that operator to a different part of the plant, put a different operator in there, or motivate that guy to work a little bit faster. I don't remember exactly how they solved it on their end, but it wasn't a problem anymore now that they knew where the bottleneck was.
Yeah. Yeah. Those are the things.
Yeah.
Those are the things that it's kind of mind blowing, because there are stuff that are really easy to deploy, and nevertheless we don't see it, and what we see is on LinkedIn what you have told us. It's a lot of bedazzle, I will say. I'm doing a lot of stuff, and everyone looks at it and says, "Oh, I'm falling in behind." And in the end, very simple things are able to create a lot of value, and to the organizations, you're able to generate value in the end.
Yep, and that's
Yeah.
going back to the circle here. That's the key for me, is to show them that value can be generated that easily, and then show them that they have people within their organization who can generate that value.
So maybe I have another question. How do you think this kind of solutions should be put into place? So when do you start it? You told us about the people. Imagine we have everyone on board, so we have something like a Node-RED that starts to create on one machine an idea of a wow effect that we should press on. How do you think the manufacturing plants should adopt this? So how do they do this rollout? How do they scale this into the plant?
Yeah, that's gonna depend again on the exact plant and all that, but it's identifying a more scalable architecture. I wouldn't, as I said kind of before, Node-RED is a really good glue that augments other platforms. You can start with it, you can start small with it, and you can kind of get off the ground to prove what's possible with it. But I know there are people out there who have done it, but it gets really hard to manage at scale. It gets really cumbersome. You either have 50 different servers running 50 different instances of Node-RED that you have to maintain and manage, and you got to deal with all the infrastructure to run that and all that, or you get one really big one that's running way too much. And I mean, if you go back to the demo there, you can kind of see how it's all tabs. Once you get 100, 200 tabs, it's impossible to navigate.
Yep.
So then it's really finding a platform that really works well, and coupling that with other platforms and other solutions, and coming up with a whole stack of options. So it would be, maybe you've got a Coreflux broker in the cloud. Maybe you've got Coreflux and some assets on the bottom for some edge stuff, but maybe you do have another gateway running. So maybe you've got something like Kepware running and connecting to the big machines where you have very, very high throughput, hundreds of thousand tags or something like that, 50,000 tags, 10,000 tags, something bigger than what you really want to do with just a small edge connector. And that's also where Node-RED falls apart. Maybe you've got Ignition thrown in there. Maybe you're doing your proper SCADA system. You're building your MES system. You're connecting to a CMMS and your ERP, and you have to identify what that full stack is. So the problem there is, if you sit there and try to identify that whole stack from day one, you're never going to go anywhere. You get stuck, you get stopped. It's too big of a project. The license cost alone gets to be too much, let alone the cost to actually implement this stuff. And then things fall apart. Things never get done. People get angry. It's not a good idea. But you need to be thinking about that. You need to have the end game in sight. You need to know where you want to go. But you don't need all the holes filled yet. You don't need to know the whole picture. You just need to know enough of it to stay on the right track. And then when you do deviate, to get back on the right track. Because sometimes those deviations are where the value comes in. More than things they didn't even expect to do can be the highest value part of the whole thing. And so then the thing comes back to getting started. It's a combination of moving, just getting started, doing something, anything. I don't care if you're throwing Node-RED on your own engineering laptop and playing with some stuff real quick, or if you're throwing it on a real server and actually running something, or maybe you've just got an ignition license and you're running through that, or you got your Coreflux broker and a couple assets. But the key is to do something and get started, and just make sure that as you keep going, you're flexible enough to let people do what they need to do to solve problems, whether that's your own employees as an end user, your own team, external people, consultants, engineers, integrators, anybody. You need to remain flexible to allow your people to provide value. But you also need to keep that map in mind, that end goal, to make sure that what you're doing is on the right track. Because if you don't have that end game identified, you're never going to get there. But if you sit there and worry too much about what's going to happen at the end, you never get started. So the goal is to get moving.
Yeah. So one thing regarding observability. So for me, it's kind of a tongue twister. Have you looked into stuff like Kibana or OpenSearch, those kinds of tools in the past? Do you think they have a place for the manufacturing industry? Because I see a lot of, I don't see them actually being used in, I see it on user experience, flight attendants, energy management solutions kind of use them, but I never seen it on the manufacturing industry. Do you think it's a set of tools that could be used? I mean, have you already took any dive into those technologies?
Too much of those specific ones. Some of the observability stuff I have looked into is stuff that can really help manufacturing. But one of the problems we run into with things like that is a lot of our platforms and applications, especially the legacy stuff, especially the stuff you're going to run into on every brownfield site, doesn't support it. So a weird balance of what can you do with the existing stuff and what can you do with the new stuff, and where in the stack does the stuff come in, right? I mean, if you've got a bunch of custom services running at the enterprise level, maybe written by, maybe managed by IT, maybe it's in a third party or whatever, then yeah, very much so. And it's stuff that can definitely help down the stack. But one of the things I've found is trying to take the ideas of things that aren't really supported by the legacy stuff and trying to do as best as I can to get towards the idea if it's not that specific technology.
Yeah, because in the sense, Influx analytics platform, so you have that concept of being able to observe each time series entries, but this Elastic Search, OpenSearch, they go a little more into checking really long strings and get all this data. So since you have done this idea using Influx, I was trying to see if you had any concept or any idea to go a little further into that.
Into those two specifically very much, so I can't really speak with any certainty. But another general thing I've found too is the closer you get to the edge, the closer you get to the actual machines and the PLCs, the more careful you have to be not to put in anything that's going to interrupt operations.
Yeah.
So I'm not saying those would or wouldn't. I haven't looked into those two specifically, but a lot of the bigger, large scale modeling things and the forcing things into a certain box and making sure you're using a specific technology do start to cause problems when you get really close to the edge. And once you start getting into the actual production.
Yeah, but yeah, maybe you're right. You are totally right. The idea was actually, maybe I didn't explain. Maybe it was the same concept. Oh, yeah. Exactly. Imagine the same concept. Instead of having InfluxDB, you have something like Elasticsearch in the end. So I was going into that approach. So in the end, it's almost similar. So you're right. You should not run this on the edge, and that's something that we are very focused on, especially because we like to put our broker on the edge device to create a kind of barrier. So you only pass the data that you really need first, and we kind of create a connection, a bridge connection through MQTT in order to create a a certain hardware firewall, so you only do the binding of the IP for that specific client through a specific IP address. So you can have your edge device with two Ethernet ports, one for going through the having access to the internet, and another one to the local PLC network. This way, you have a separation concerns. You have two networks, and you don't have to mess around. So that I was asking to see if because with Influx you can go a little, you can create your own model, maybe, and with that model try to guess what you want to predict, and yeah.
Influx is very specifically, it's just storing that time series data. There is no analytics built in. There is none of that. It's just storing it. So then you're going to need another node to come in and do something with that data. So there's API connections. They've got their own ways of connecting to that. At the edge, the big thing for me with something like Influx or Timescale is another good one that does the same thing, is it's directly replacing some of the more limited industrial historians. So you're losing some of the dedicated features. You're going to have to build those yourself on top of it. But you're at least able to use open source tools, do your own analytics layer on top, your own dashboard layer on top. Now you're using a tool that has good connectivity options versus some of the Thatcher Talk historians and OSIPIs and things like that, at least in my experience, you can work with them. You can get a bridge, go to SQL, jump into Node-RED, build a dashboard that way. But that's a lot of steps to get your data.
Yeah, but I kind of like the whole architecture that you built. Yeah. It's quite You probably could predict when our machine or coffee machine was going to break down.
If we had enough data.
And for me, it's very important.
Yeah. Hugo, I think your mic's off. Can't hear you.
No, it's okay. Maybe I think for me, at least what I wanted to exchange with you, I think it was very, very good to know the points that you told us about, especially the number one issue, which are the people that we are working with, that really understand the value of what IoT means, what we really can achieve for the manufacturing industry. And this small example was just us playing around, but at the same time, we were really talking about something that was important, which is to give these first steps in order for everyone to see, oh, you can get data and you can handle that data. So imagine if you can do this, you can do that. And it begins from that point. It starts from that point, and it goes to a full-scale system, as you told, with a specific architecture that you're able to scale. So, it was very, very good to have this afternoon.
Just Dylan, webinar. Sorry, if you can hear me. Usually, we see a lot of issues, let's say, from the customer side, or when we try to do an integration to separate the concern today for changing to cloud systems, and this approach that nowadays is so crucial, let's say, for creating this value. Do you still see this a lot? And usually, how do you manage this?
We do a lot of things on premise, to be honest. Also, I'm a little bit in the middle of that too, because on one hand, the cloud offers a lot of really good stuff, but especially with manufacturing, the quantity of data you're talking about, one of my big fears in the future of manufacturing is going to be what happens when you can't access your data anymore. What happens when you want to move to a different cloud provider? The cloud offers really good ways of backing up and being able to restore and get your data, but I really, really don't like when the cloud is the primary store of that data. It makes it really difficult, sometimes impossible, to get your data back. So when it comes to the cloud, I like it for compute. There's some platforms that do really good stuff in the cloud. You can run your analytics, you can run your brokers, you can share things, you can display things and all that. But most of the needs of what we're doing, especially in these early days with people who are just getting started, cloud is pretty late in the game for a lot of people. It's not day one. Day one is how do we get the data? How do we collect that data? where do we store that data? How do we store that data? Maybe it is in the cloud, maybe it's not. And if that stores might be the first time you're looking at the cloud. And then from there, it comes through that. But a lot of the needs I see in the early days are, how do we connect everything together? How do I get some data points off this? How do I drive a dashboard? And once I start mentioning cloud or looking like that, I get a lot of blank stares from people on site, especially your plant engineers, your maintenance guys. People have been doing this for a long time, especially when it comes to the operation side of this. The cloud is scary. You're no longer in control of whether or not it works. You don't own the infrastructure. They may manage it better than you, but there's still that feeling of it's not mine anymore. And again, keeping this with the people, that's a very valid feeling. So then the question is, how do we keep it in their hands? And especially early on, before they have trust in these systems and these solutions, keeping that on premise. Maybe it's still just an old school VPN they can log into to see their dashboard from the house or something. And then once you do move to the cloud, you've typically gotten through that hurdle where people actually trust the technology. But until people trust the technology, I don't even address cloud personally.
I think I want to wing in on this one. It's really important that you mentioned that, because one of the things that when we started Coreflux, we started in order to be open. So we're able to connect multiple, not only the devices itself, but the systems, because you really need to have something that is open, because the data that you create, it's your own data that you are going to store, and you need to be the owner of that data. So what you're saying, all of them, the platforms, I'm not going to mention other names, but there are a lot of platforms that provide OEE dashboards that really create standard solutions. But in the end, if you want to get the data in order to analyze something, you will have to pay, because you don't know the data that you create, which is very strange, because every day you are sending and you are providing that data to someone else, and that's why we are trying to bring what we have on the edge and at the same time on the cloud, and keep it open, in order for people to understand they can use specific, like we were discussing, to use Elastic for this, to use OpenSearch, to use Influx, but you are the one keeping the ownership of the data. That's why we also created this connection with DigitalOcean. I don't know if you know that, Dylan, but the idea that we are talking to and what we are delivering is that you are able to instantiate the broker, the cloud broker, and you are able to, within our platform, that's what we are building now, to instantiate a database on the DigitalOcean, but with your account. So it's your account that you are bringing your own cloud. And what we are doing is that we are orchestrating the creation of that cloud. We are not the owners of the database. And even DigitalOcean is not the owner of the database, because it's only providing computation. It's only giving you memory, CPU, and disk, and that's what you want. If you don't like what you have from DigitalOcean, okay, it's easy. You just migrate the data to another place, and that's it. Because those guys that are afraid, I know what they are afraid. They are right. You should keep the data. They are totally right. But if they don't know that other stuff exists, they will also not be able to do it. So it's something that the platforms, the integrators, everyone that's involved, at least from our perspective, they should go into what we call an open architecture. So in order for the customer to feel that, okay, nothing is locked, I don't see any vendor lock in here. I can change this guy from another guy. I don't like Coreflux. Let me take them out. I can place another one. So that way the customer is able to feel, the client is able to feel safe.
So the same thing I've always said too, even early days as an integrator, even when I was just doing PLCs and learning it out the gate, is a big thing for me is I never want my clients or my customers to feel like they have to work with me. I never want to lock them into anything. I want them to want to work with me. We're providing the value, we're providing a good service, and they come back because they want to, not because I locked them in and forced them to keep coming. And that's exactly what I hear you saying there.
Yeah, that's something very important. Can I quote you?
Yeah.
But I can say, maybe I can use that sentence like I was the one saying, but you're right.
Yeah.
That's the thing.
And the big thing too, the
Yeah,
open architecture you're talking about too comes in, and when everything's an open architecture, nothing's exclusive anymore. It's not this platform or that platform. It's I can use this platform because it solves my problems in this part of the business, but everything's open and I can use that same data source to power this platform in a different part of the business. And it's it's not one platform or another. It's not one thing or another. It's not one solution or another. It's an open architecture that you can just plug different solutions into. And that's where
each one has a specific function.
Because at the end of the day, none of this technology matters if it's not solving a problem, if it's not helping people.
Yeah, if it's not creating value, then what's the purpose? So it was a great pleasure just to hear you guys and talk with you guys. And also, Dylan, where can people find you and your work on the internet?
I'm pretty active on LinkedIn, so if you guys have any questions or need to reach out to me, that's going to be the best place to get started. There's some GitHub repos that show some of these stacks too that I've put. You can get to those through LinkedIn as well. At the end of the day, just keep learning and stay curious.
Thank you everyone for watching and listening. Whether you're just getting started or you're already a master of IoT, we hope to inspire you to find new and better ways to make your data work for you. We're happy to answer any questions you may have regarding this webinar or Coreflux in general. Leave us all your questions and comments below or email us at contact@coreflux.org. And make sure to connect with Dylan on LinkedIn. All of us here at Coreflux are grateful for his time and effort in putting this episode together. As a producer, I can tell you we hit a few bumps on our side and he was extremely patient. Alright, consider subscribing if you want to see us make more content like this, and if you really want to help us democratize IoT, tell people about Coreflux. Thank you, see you in the next webinar.